Okay guys, I created a video not too long ago that said that the Earth was a globe, and I had a lot of feedback on that. Good, bad, ugly, whatever. What I wanted to do right here, I said I was going to prove that the elevation doesn't really matter in the curvature of the Earth. So, and then I'll get into a picture that I've taken that I want to go through, and I have some questions, because I have some questions on it. But first of all, I just want to show you that I've made this spreadsheet that shows the curvature of the Earth in inches as well as feet as well as miles. So you can take it however you want. But in any event, this is the radius of the Earth, and to figure out the sagitta, or the height, the drop, the curvature, however you want to talk about it, whatever you want to call it, you have this formula up here to figure it out. And I've entered that formula into my calculations. So if my radius is 3959, or 12, my radius is my Earth is 12, my half chord length is 12, my height should be 12. That equals out, and I can prove that in that I've done all the formulas. The only entering number I put is the miles here at first. The rest is formulas to create, and then the sagitta, the height, or the curvature, whatever you want to call it. Okay, so 1 mile, 8 inches, and that matches this Earth curve calculator that says 1 mile, it's 0.6668 feet, which in turns is equal to 8 inches. Okay, if we do, so I've done this, and I've gone through and I've made this formula, and you can see that I went all the way down to 3959, and that's 3959 feet. So the calculation that I have created works. From this formula, you can see that you can do a calculation, 1 feet, 8 inches. So that's where I'm taking my formula, is from this wonderful mathopenreference.com. You can look it up yourself if you want to question it. So anyway, let's go back to this where I've said, okay, it's 8 inches at 1 mile. Elevation doesn't matter. So what I've done is I've taken 4490. That is the elevation of the Utah Lake, right here, 4490. I know you can't see that. 4490 down here, 4490. That's the elevation. So I put it as 4490, and then I've taken that number, 4490, that's how many feet, times, plus this number, which is how many feet the radius of the Earth is, 3959 miles. So I've added that to make my elevation take into account. Okay, so that number is 20,908,010. Now, if I take this and I say, because remember I've done all these calculations, it's calculating according to the feet. So if I take this and I say 20,908,010 and hit enter, you can see these numbers did not change. Okay, up 10 miles, 800 inches. If I hit undo, watch the 800 inches. Doesn't change. 800 inches still. Sea level, elevation, still 800 inches. 8, 8, 8, 32, 72, 128, 200, doesn't change. Now when you start getting into further miles, further distances, let's take 50 miles, for example, 20,002 inches at elevation. We go undo, at 50 miles, 20,006. So it's 4 inches difference in 50 miles. Proving my point that it's negligible. You don't need to worry about elevation. What you really need to worry about is what the curvature really is, because it's not really a true perfect sphere. It is a, what they call a oblate spheroid, which is wider at the equator and shorter at the poles. That's what they tell us anyway. I don't know. I've never been to space, never seen the Earth from space. I've only seen a couple pictures. But, so I've proven that, that's what I want to do, is prove that the calculation of the elevation doesn't matter. Okay? Move on. So what I've done is I actually stumbled across a picture that I took when I was out playing around with stuff. Oh, also I wanted to show this real quick. So I did this AutoCAD drawing to scale, which shows the Earth, and all these lines, they match up exactly with how far the drop should be. Okay, if it was a perfect sphere, I know it's not a perfect sphere, I understand, but it's close enough. Okay, so all of these things drop at, 5,280 feet, 1 mile, it drops 8 inches. This is the Earth curve line. Okay, so all of that, I've done the calculation, it works. My calculations are correct, and that's all I want to prove by that is prove to myself the calculation is correct if the Earth is round. Not round, a ball. Okay, so next, we can close these here. So the next thing I did is I went out and I said, you know what, if I should be able to see curvature, I should be able to see stuff disappear, which I kind of thought I proved in the last video, going from this deck over here over to this one over here, which is 7 miles. I said, okay, I'm going to go over here and I'm going to look further across the lake and look way down to here. According to the curvature of the Earth, sorry, I had to pause real quick. According to the curvature of the Earth, if we come to here at my eye height at 0, my target distance, no, I want to say I'm 6 feet tall, right? My distance I want to look is 15 miles, doesn't matter. 2.99 miles. Let's say I'm 7 feet tall. Or I'm taking a picture and I'm off the water by a foot, so 7 feet tall. So my curvature, my horizon distance, which means as far as I can look here, I'm standing here looking this way, my horizon is at 3.2398 blah 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 miles. Anything beyond that should start dropping down and I shouldn't see it. Right? Doesn't matter what the mile is. We can say 14, we can say 10, we can say, that doesn't change. The only thing is your hidden stuff changes. Say 20, now it's 187 feet here, but I'm not worried about that. I'm worried about the horizon right now. Okay, 3.2 miles. So if we go back to Google Earth and we say, where to draw on this line, this is where I was standing, looking out from here, 3.2 miles, which you can see 3.23 miles is right here. So my horizon should be right here. That's as far as I should be able to see, and everything beyond it should start to fall away. And my horizon should be completely flat. It should be totally flat at only 3 miles. You're not going to be able to see a curvature at 3 miles anywhere, right? I think we'll all agree with that. So I'm looking this way. I'm actually looking down to here. So let's say the telescope is pointed from there up to this point here. Okay, I'm standing right there. And let's look at the picture. Okay, oops. There's my horizon. Here's a picture of it. Now this is just for a line for future. Hold on, I'll get to it. Okay, but that is a pretty flat horizon. And to me, that horizon is great, but it should be at 3.2 miles. Anything beyond that should start to fall away. I shouldn't be able to see it, right? So 3.2 miles. Again, somewhere in this vicinity. Well, I'm looking across, and that mountain over there, the shoreline, we go back to Google Earth, is 13 miles, all the way down to here, right? What else is in my view is this great big mountain here, which is this mountain right here comes down, no, sorry, this mountain right here, okay? Which is this mountain here. So there's still water beyond it, so it goes quite down to here. So if I'm looking there, and I come back to this point, close enough to where, no, pretty close, almost. 19 miles, let's just say 19 miles, okay? So it's 19 miles to here, 12 miles to here, and then it gets closer as I get closer. Right here is about 4 to 5 miles. But my horizon should be at 3.2 miles, remember? 3.2 miles should be right there. So now if we zoom in here, okay, and we put this line, just a crop line, just cropping the picture. I'm not going to really crop it, but just showing you. If I put that line right at the horizon, okay, we can agree this is mountains, this is water, my horizon's right here. If I drop this down to my horizon, we'll zoom in and make sure we get it right on the horizon, best we can. Okay, water line, this dark line right here. Maybe this one. We'll say in between. I mean, it's kind of a mixture between this line, these two pixels right here. Okay, this line, and this line. So we'll put it right in between them. So there's no dark blue under. Well, we'll leave one dark blue. That's fine. One dark blue, or one lighter blue, then darker, and you're okay. Now we're really in the water. Okay. Remember, land, water. Okay, so I drop this back down to 1 pixel of light blue. I just kind of scroll out a little bit. We zoom over here, come over here, see the mountains. Okay, we come over here. Here's that mountain that's in front, and then from here, this point starts to get further away from us. Remember, that mountain starts to go further and further away, right? So our distance is further, which means we shouldn't see as far. But anyway, our horizon should still be at 3.2 miles. We keep coming over here, and now we're looking further and further and further. What I find is interesting, if I live on the globe Earth, I shouldn't be able to see beyond my horizon at 3.2 miles. Then why do I see water above that line where my horizon is over here? Remember, I'm actually above. I'm a light blue pixel above. Remember? Light blue, light blue, light blue. Okay, we'll take it right there. Let me come back over here. My sugar line is there. Well, my horizon line, sorry. I keep coming over here, but now it's dark again. Why is it dark beyond my horizon line? Why am I seeing water there? I shouldn't see water beyond that line. Let's drop this back down. Okay, this time we're going to put this line at the horizon. Okay, so there's, you can see this is where it really kind of starts to get blurry. Then this one, then this one. Now we're really into the water. Okay, so let's put that down at right there. One blue. Let's put it right there. Let's make it even more drastic. Right there. So we've got two kind of darker lines now, just because the way it crops, it shows it lighter versus darker when you're cropping stuff. Anyway, you drop this back down, put it there. So there's a light blue, kind of, if you're going to call it blue, lighter color, then darker. So we'll do one. We'll go right in between those two. Okay, so there's one light blue, light color right there. Okay, so that's at the horizon over here. We scroll back over. What happens to our horizon? It's at a different height. Now we have a light blue, and there. So we're kind of 2 full pixels, if not 3 pixels. Oops, sorry. 3 pixels different. My question is why? If I'm really supposed to only see 3.2 miles, why can I see water beyond the horizon here? My horizon should be 3.2 miles. That's right in the center of my view. I put this back down here. I scroll over in my picture. It takes too long. Zoom out. I can see water beyond what my horizon should be. Which kind of makes me now question whether or not this Earth is a ball or not. Done some more research, and I'm kind of leaning now. I know many of you are going to say, what? You're crazy. Come on. You can't really believe this, right? Well, I don't think I should see the water back there. You know, if that is really my horizon, I should be there. Why am I seeing water beyond what my horizon should be? I shouldn't see that. Okay, we put that back up there. You guys can all say what you want, but the horizon has changed over here versus over there. And in my mind, if anything, if it's a globe, it should start to drop off this way, being that it's round from my center point down this way. You're not going to see that, but it's actually higher. And my reasoning is I can see farther because it's completely flat. And I can see the water that extends beyond. Distance 19 miles. Remember, that's 19 miles versus 12 miles. So the shore is closer, which means the water is further out there, which means I can see water above that line. Anyway, my time's about up. Let me know what you guys think about this. It's kind of got me puzzled now. I'm not ready to jump ship, but I kind of think it proves, I don't know if it proves anything, it proves the water's flat, proves that my horizon isn't really my horizon. It really isn't at 3.2 miles. Remember, my horizon is clear up here. I shouldn't be able to see beyond this. Everything else just, and my horizon should be completely flat from this point over to this point. It shouldn't be up or down either way. Anyway, take a look, guys. And you can see the water is actually closer here. I mean, it's above the horizon here. Why is it above? I mean, this is 5 miles. It should be still 3 miles. I shouldn't be able to see water there. Anyway, good luck. I don't know what you think.